Okay, let's do a quick coaching.
Hey, give me my pencil back there.
And then I want to hand out your practice stuff, and we want to start gathering the pieces up and getting ready for a quiz on Wednesday. Okay, so let's do a quick cotangent. First of all, this is what a cotangent looks like. Now, it has some similarity to a tangent, but it's also different than a tangent. So, can somebody tell me what the similarity is to a tangent? Got two asymptotes and a curve in between. Notice how far apart are the asymptotes? Pi. So just like the tangent, the period is pi, right? What's different about it?
It's curved the other way.
It's upside down, it's decreasing. The tangent is an increasing function. This is decreasing. And what else about it?
It causes an x-axis.
The asymptotes are in a different spot. Remember, your tangent goes through the origin, right? Your cotangent has an asymptote at the origin. Remember, when you phase shift, when you pick a curve up and move it, it's the origin that moves. So, in the case of a cotangent, let's say we had cotangent 1/3 x minus pi over 5. All right, here we go. There's a phase shift in this problem. Would you agree? A horizontal shift? Braden, what are you doing there on your iPad? Excuse me. Huh? Taking notes?
Yeah.
Okay. You know, someday I'm going to come back there and look.
All right.
Now, what did happen at the origin, which was an asymptote, is now shifted pi over 5 to the right. So I have an asymptote at pi over 5. I have another asymptote somewhere, and I have my curve in between. There it is. That's your cotangent. That's all there is to it. Now you just need to figure out the labels. Now, ideally, perfectly, how far apart are the asymptotes? Pi. Tan and cotan have a period of pi. But I stuck a dreaded number in there. So what does that number do to my period? Oops. It divides it. So what is the period of this curve? Pi divided by 1/3, or 3 pi? Now what does that mean? That means that from here to here is 3 pi. So how will I find this label right here? From here to here is 3 pi. How will I find it? Add pi over 5 plus 15 pi over 5. So this is 16/5, or 3 1/5. Start at 1/5, add 3. 3 1/5. Now, the dot is always right in the middle, so I need the average of 1 and 16. Oh, shoot. What's the average of 1 and 16? Well, 1/5 and 16/5 makes what? 17/5, and half of that would be 17/10. And there you go. You're done. What's the amplitude of that guy? No amplitude. Remember, the only trig functions that have amplitude are sine and cosine. Everything else shoots up and down. We said the period was 3 pi. What's our phase shift, our horizontal shift? Pi over 5, right? Pi over 5. And what about our vertical shift? We don't have one. 0. Okay? Kate and White, you look like you're a little dazed there. This take a look. Oh, those are the answers. Let's hand it out this way. All right, let's take a look at what we're going to be expected to do on Wednesday. There's one for sure.
It's kind of tricky
All
that.
right, so here we go. What are we going to be expected to do on Wednesday?
Didn't they call it that? I think that's
What was it you said? You're like, dude, I never get called that.
I was taking that. Like I wasn't, but I was.
Level 2 law. See, it's tricky, you know,
Notice?
level 2.
Being the clever person that I am, this paper is called PreQuest. What do you think that means?
The
It
review for the
looks
quest.
just like the quest, okay?
What's that?
So here we go. Things might be in a little different order, but the problem types are the same. Oh, look at number 1. Have we ever seen anything like number 1 before? Yeah, we've taken 2 quizzes over it, and these quizzes had better be good that I grade today. Cosecant 5 pi over 6, step 1. So that's the cosecant of what?
150.
150, good. That should not take you very long. You've done that a lot. So 150, here we go. That's the key right there. How big is it? 30. So we got a 1, a 2, and a root 3.
Negative.
Put the skids on. Anything negative? Root 3. I need the cosecant. What's the cosecant? Cosecant is hypotenuse over opposite. Right? Hypotenuse over opposite, so that would be 2 over 1 or 2. Done. Easy. 125 degrees is how many radians? What's our strategy? Pi over 180 equals x over 125. So x equals 125 pi over 180, which reduces to something, let's see, 5 goes in 25, 5 goes in 36, I think that's it, 25 pi over 36. Number 3. We're solving for x. Now, there are a couple of different ways you can do this problem. But one way that we did, we talked about these in class, is we simply said the cosine of 30 is 6 over x. Now, why did I choose cosine? Because relative to this angle, this is the adjacent side, and that's the hypotenuse. And so x cosine 30 equals 6, and x equals 6 over the cosine of 30. Would you agree with that? Now wait a minute. This is a no calculator exercise. Do I really expect you to do that without a calculator? Yeah. Because what's the cosine of 30? Can you find the cosine of 30? Is 30 special? Yeah, 30 is special. 1, 2, root 3. Nothing's negative because it's in quadrant 1. What's the cosine of 30 degrees? What's the cosine of 30 degrees? Root 3 over 2. So 6 divided by root 3 over 2, which is 6 times 2 over root 3, which is 12 over root 3, or 12 root 3 over 3, which is 4 root 3. So the answer to the problem after all that arithmetic is 4 root 3. Will there be a problem like that on the quiz? Yes, indeed there will. Number 4, tangent 300. Oh my gosh, here's another one. Tangent 300. How big's my reference angle for 300? 60. So then negative root 3, a 1, and a 2, if I got that thing labeled right. And what do I want? Tangent. What's tangent? Opposite over adjacent, so negative root 3. Ben, you awake? Pay attention. All right, number 5. What do you think when you look at this picture and see all these letters? What do you automatically think? What pops into your head? Arc length equals radius times radians. So the arc length is 10, the radius is 6, and we don't know what the angle is? But we can find it, can't we? What's it equal? 5/3? What's the unit on that 5/3? Radians. 5/3 radians, yeah. Remember doing that back a few days ago? Or maybe more than that, maybe before Thanksgiving, I don't remember. But you remember it? Jogging some memories. What are the period and amplitude? Notice it does not ask you to sketch it, although you certainly could. It says, what are the period and amplitude of this curve? Now, first of all, be careful. This amplitude question can be tricky, right? The only functions that have amplitude are sine and cosine. So I don't care what number you've got out here. If it's not a sine or a cosine, there is no amplitude. You know I'm going to try to trick you. Now, this is a sine, so it does have amplitude. The amplitude is positive 3. Remember, amplitude is a positive number. It's a distance. It's a positive number. I know there's a negative. What does that negative do? Turns the picture upside down, but it doesn't have anything to do with the amplitude. All right? Now what about period? What's the period supposed to be? 2 pi. But this one has been divided by 4, so the period is pi over 2. Name a negative coterminal angle for negative 48. Name a negative coterminal angle for negative 48 degrees. How do we find coterminal angles? Add or subtract 360. Since we want a negative one, it specifically says find a negative angle, we will subtract. So what are you going to write down as your answer to number 7?
Negative 408.
Negative 408.
So negative angles. Oh, so I'm writing this now. What was it? Say that again.
To find coterminal angles, you either add or subtract 360.
Okay.
Or you add or subtract a revolution. If it's in degrees, that's 360.
Yeah.
Since they specifically said, give me a negative answer, I'm going to subtract 360.
Yeah.
All right, now we got another triangle. And it says, what's the tangent of that angle right there? What are we missing here? We're missing the side of the triangle. So can we find that side? Doing the Pythagorean theorem. So that'll be 49 minus 25. Is that 24? So this is the square root of 24, which is 2 root 6. Now why did I need that? Because tangent is opposite over adjacent. So the answer to the problem would be 2 root 6 over 5. Remember, this is your theta. So there's your opposite and your adjacent. So far, it's pretty easy. Right? Feeling pretty positive. Is sine 5,000 positive, negative, 0, or undefined? Now, you're not asked to find the sine of 5,000. You're just supposed to tell me if it's a positive, negative, 0, or undefined number. Okay, 5,000. Let's think about that for a minute. What about 5,000? What? Yeah, it's a lot of revolutions, isn't it? So let's see how many revolutions it is. Let's take 5,000 and divide it by 360. I got 320 as my remainder, but I'll let you check my division. What does that mean? What does this tell me about about 5,000 degrees? What does that tell me about it? It goes around 13 whole times, right? And then what does it do? Goes an extra 320. So if you drew it, you'd spin around, spin around, spin around, but then ultimately you'd have this extra 320 degrees. Now that's in quadrant 4. What do you know about points, x's and y's, in quadrant 4? We know x is positive and y is negative, right? And we know r is always positive, right? Now the question is sine. Sine is y over r. That's the definition. So tell me about that. Y over r is going to be what kind of a number? Negative. You could also think about making a triangle. Wouldn't the opposite side of the triangle, now this is going to be a 40-degree angle, so you don't know the numbers, but wouldn't that be negative? And that would be positive? And this is always positive? So if you did opposite over hypotenuse for sine, you would still come out negative? You could do it that way too? When would it ever be 0 or undefined? What would have to happen to get a 0 or an undefined? It would have to end up on an axis, because then you have zeros and ones, right? Cotangent pi over 2. Geez, here's another one. There have been like 5 of these. Cotangent pi over 2. What's pi over 2? 90. Finding the cotangent of 90. Here's 90, speaking of quadrantal. What are the coordinates at that point? 0, 1. So x is 0, y is 1, r is 1. I need the cotangent. What's the definition of the cotangent? X over y. When I put x over y, I get 0 over 1, which is 0. So the cotangent of pi over 2 is 0. Draw a course of 301 degrees. Now, we've been drawing angles here a lot. What's going to be different about when I draw this course of 301 degrees? Starts here and goes this way. So would 301 be over here? Now we had a quiz and you had to do something like that, and some of you did not draw the vector. You need to draw the course. So if this ship is sailing, that's where he's sailing. Okay, why is 301 there? Because that's 90, that's 180, and that's 270. So 301 is just a little past 270. And finally, the last one, the cosine is 2/3, and I'm in quadrant 4. So I'm going to draw my butterfly bow tie in quadrant 4. And the cosine is 2/3. So what does that mean in terms of my triangle? Cosine is 2/3. Adjacent over hypotenuse is 2 over 3. Now I'm going to do what I did a little while ago. I'm going to find that third side. What would that third side be? Square root of 5. Square root of 5. And actually it's negative. Would you agree with that it's negative? 9 minus 4 is 5. Square root of 5. And then your job is to find all the functions. So we're going to find sine x, cosecant x, tan x, cotangent x. And they gave you the cosine, which is 2/3, so you automatically know the secant is 3/2. Those are like, well, one was given and the other was an automatic. So now we got to fill in the rest of this. So what's our sine? Based on your picture, what's your sine? Negative root 5 over 3. Which means your cosecant is negative 3 over root 5, or negative 3 root 5 over 5. Right? Tangent. Negative root 5 over 2. So your cotangent is negative 2 over root 5, or negative 2 root 5 over 5. In your packet, that's the quiz right there, folks. That's what you need to know. So if you're sweating it, quit sweating it and learn that stuff. It's easy. Go to page number 6. Go to page number 6 in your packet.
We did the video.
Yeah, the big packet, not the review packet, but the big packet. Go to page number 6. See how it says quiz 4.1 to 4.5 review?
Yeah.
This is an old one for an old quiz, but the material is the material, so it's ought to be pretty close. So look down through there, because we don't have a whole lot of time. Look down through there. There's 7 questions, but some of them have multiple parts. What on there looks like something that maybe you have a question about? I do want you to not worry about, in number 2, it mentions frequency and sketching. On this quiz, you will not be doing frequency or sketching, so you can cross those out. But we can talk about the rest of that stuff if you want to. So what on there do you have a question about? It looks like you need to do. Yes.
Number 6.
Number 6. Find the length of a shadow cast by a 16-foot pole. So I'm going to draw my 16-foot pole standing on the ground. And I want to know the length of the shadow if the angle of elevation of the sun is 27 degrees. So here's the scoop. The sun is up here shining somewhere, and this pole is making a shadow on the ground. Can you visualize it? I know that the angle of elevation of the sun is 27 degrees. That means if I look up at the sun, which is dangerous, so don't do it, but if I looked up at the sun, the angle my head was tilting through would be 27 degrees. Oh, John, I handed these out a long, long time ago. I don't know. Take a picture of somebody else's. Now, I need to find a side of the triangle. So what do I do? What? The tangent of 27 is 16 over x. So x tan 27 equals 16, and x equals 16 over the tangent of 27. Now this is sort of like the one that was on our quiz, but that's a 27. It's not a 30 or a 45 or something special, so that would have to be done on the calculator. So you would just type in 16 divided by tan 27, and that would give you the answer. If that were a 30, then I could have you do it by hand because you know how to find the tangent of 30. Okay, anything else you see on this paper? All right, tomorrow what we're going to do is a little bit more of this review, whatever you need to do in terms of this review, and then we'll go ahead and start our exam review. Okay? Do we, by any chance, we don't have a long period tomorrow, do we?
We have classes.
Yeah, we do.
I don't think we have any more.
Well, I tell you what we could do tomorrow. We could actually, if you would rather take your quiz and get that over with, tomorrow we could do that. So we'll talk about that tomorrow too. But right now I'm done. You've got everything you need. I need to edit this video that is like 16 minutes long of empty space.